I wanted to make sure that you had some really good visuals to see the difference between the different types of plate boundaries that occur. So I've got really 4 slides that show this for those who like a number of different examples. So divergent, this is my Mid-Atlantic Ridge and other ocean places. This is also where we've got the emergence of new water bodies like the Red Sea occurring, where we've got upwelling occurring here, and then those convection currents are going to push this to either side, and then we've got a seam and a thinning out where magma can emerge. We've got a convergent boundary where we've got subduction taking place. This is a really sharply illustrated subduction zone, which means my volcanoes are going to occur right about on top of that volcanic earthquaked environment. So earthquakes and volcanoes are going to happen exceptionally frequently on top of each other. And then this is the transform boundary. This is what we see in Southern California, but we also see transform boundaries occurring alongside divergent boundaries. So with that, couple of examples of convergent zones. We have discussed the subduction zones that come in under a continental landmass and then produce upwelling. So this is the Andes in South America. We can get environments in the middle of an ocean body, which is going to create an island arc. So this is Japan, this is the Philippines, this is Java and Fiji and Sumatra. And then we can get convergent plate boundaries where we've got 2 land masses coming together. And the classic and best example of that is India running into Asia, creating the Himalayas. All right. With that said, because both are of a lighter landmass, we get a lot of uplift, which is why the Himalayas are so tall, is because we've got a big crumple zone happening of very light material, which means nothing really is subducting deep into the asthenosphere. So we don't get the same amount of downward energy as we get upward energy. Second is this divergent rifting, and we get those in the centers of oceans frequently. Many of that occurs starting with where we've got a landmass splitting. So we talked about the Red Sea before and mentioned the African Rift Valley, but haven't really shown it to you because this diagram does a really nice job of it, and I wanted to isolate it on its own so you can see we've got 2 boundaries coming together, creating a foci point, and then the energy is transferred down through in this direction towards the south, and we're creating that string of water bodies that I had mentioned that are going to eventually open right up and then join with the water bodies right here. So you've got that. So this landmass here will become isolated, but is functionally part of the Arabian Peninsula. And then the last one is this transform boundaries, many transform boundaries around the world. And what you end up getting is a displacement of features laterally. And you can measure the rate of change on this by measuring the amount of displacement that's taken. So in the case here where they're showing a road, you can measure how much the road is shifted over a particular time when the road was constructed to the time of measurement, and that'll tell you how fast that displacement is taking place.